Hello viewers, welcome back to another episode, and this episode is a bit different to my previous videos because normally you will see the scenes in a chronological order, and I planned this for that video as well, but the things that happened needs another approach. So now I will do some comments in the first scene before the actual video, and therefore you will see also a second welcome scene. The big difference is you see the result in the beginning. You see the VAXserver 4300, and it's perfectly running for now 3 days. Started it several times, and the PSU is working, and I brought the server back to life. You can see over here there's a cluster statistics. It's like an early task manager, but it's refreshed every 7 to 8 seconds. It's only one node at the moment, this machine, but it's working. Another difference is that I need a longer script or longer nodes for this first scene, because I have to be sure that I always say everything what I want to say. And usually I do not need notes for my videos, only for technical specifications or names or something like this, and the rest is I talk what is coming in my mind. And yeah, if you only want to see that the machine is working, you can quit the video now, but if you want to rest it, you can hear me talking about 15 minutes, a lot of nonsense about this power supply. So the whole project took me over a week, and also some ideas and some solutions developed during that week. And maybe if you see the solution later and you are an electronic expert, you think my solution is completely awful and I shouldn't do that, write it in the comments and say why it's awful. But from the actual standpoint, it's perfectly working. And another thing I have to mention is if you have a similar issue with your power supply and you have that specific power supply, maybe that my solution isn't working for you because your issue is caused by a different issue in a different voltage rail. You will find online a circuit layout for the machine, but it's not official. It's made by Reserve Engineering, and it's not 100% correct, especially in the minus 12 volt is an error. But I have another power supply with more issues than that one, and I've disassembled the 12 volt board in parts and checked the layout and checked if my solution is possible. But I do not trust it 100%, therefore I will change the whole 12 volt board with a modern power supply. It's possible. Aaron S. Jackson did it. I will link the solution below, and maybe there will a fourth part of the power supply video series in someday. In general, I'm not a professional in electronics. I'm just a hobbyist, and I've learned a lot while working with the PSU. And you read often, do not something without experience, but the question is, how can I get experience? And therefore I will talk a bit about safety. Usually I inform myself before I do something and check if it's possible, and I do a bit of research. And in this case, you will see later, I did a mistake while my repairing process. And in general, this system will not work unattended, and I've tried to avoid electrical shock because I do not want to touch anything in the PSU, especially the capacitors, and will unload the capacitors, and I have always a fire extinguisher ready to hand and things like that. And I thought also of burning circuits, but I do not think about burning cables. The mistake you will see later is that I choose 2 small cables, and the cable melts, one cable melts, and but unfortunately the PSU switched off. The logic is quite good in this PSU and nothing else happens. It smells a bit like burnt plastic, but that was everything. And I decided to show this mistake as well, but I want to comment this mistake before. This is the reason why I choose to make some this first scene. You can see the ending. And it's also a part of the suffering or the passion of retro computing to see that errors can happen. Okay, then let's start with the video. Hello viewers, welcome back to another episode on my channel DEC Computers, or I should rename it to Don't Start with Retro Computing, because you have to deal with issues with power supplies. And this is the third part of the power supply issue from my VAXserver 4300. The last time I've changed some capacitors, but that did not solve the issue. Therefore, I have to do some more measurements to find where the issue is located. Over here is also the power supply from the VAXserver 3100, but this power supply has some more serious issues. This is the reason why there isn't new content on that machine, because I have to do some more investigations on that power supply. And I want to concentrate on the VAXserver 4300 power supply first. To the general topic of retro computing and issues with electronics, I found an interesting video from Jeff Gerling with the title "Retro Computing Enthusiasts Are Masochists." And it's quite interesting because he describes the general little problems with old computers and what can break and all that stuff. So let's have a deeper look on the power supply, and every time I have a deeper look on it, I find it more interesting because the design of the power supply is quite interesting. It starts over here. This is the inside, and over there is a switch, but it's not an ordinary switch. It's an automatic circuit breaker. So if anything went wrong inside the power supply, it will switch off the power. And this board here, I think this board is only rectifying, and there's no switching component on that board. And this power supply is capable to use 120 volt and 220 volt automatically. There's no switch like on other power supplies in the early 90s or late 80s. And after that, it goes with this cable to a board on the other side. It's here on the left. This is the input. Here's some other stuff is happening, and on the right is logic. I will cover the logic later. And from that it goes to these two connectors, and these two connectors goes to the two boards we've seen in the previous video, the 12 volt and the 5 volt board. And these two boards are two separated switching power supplies, because you have over here and over here there's a PWM controller. And here's a little transformer to isolate the primary and secondary side of the power supply. And here is a transformer for 5 volt, for 3.3 volt, and for 12 and minus 12 volt. And over there is the rectification on the secondary side. This is quite interesting because this power supply can control the 12 volt and the 5 volt separate. And this, I think the reason why they chose that design is you can use this power supply in a VAX 4300 like I do without any hard drives, and then you need more 5 volt power and less 12 volt. But you can use this power supply also in a disk expansion with 7 disks, and they need a lot of 12 volt power and less 5 volt power. So last time I've changed these 3 capacitors, but I've did not mention that this thing here is a capacitor as well. I have a second one here, and this capacitor is for is in the rectifying of the 12 volt rail. But you don't get these capacitors anymore. I found a capacitor with the data, because this is low ESR, and the only capacitor I found is this one from Nikon. I think it will fit if I have to change this capacitor as well. I have a second board over here from my spare one, and I removed it, and I've removed some other components, and I will try to rebuild it in some parts. And if the issue is located on the 12-volt board. Therefore, I will solder some small wires to the output. These are small wires. And then I can measure the output with an oscilloscope. And I can see which of these 4 output lines, in which of the 4 output lines is the voltage not correct. Because, I've said in the beginning, there is also some kind of logic here. This is the connection, and the connection from the logic comes from the backplane and goes into the logic board. And this logic does several things. The first thing is to control the voltage. So the voltage gets back, and if the voltage is too high or too low, the logic switches off the power supply. And I think this is what's happening. But this logic does a lot of more things. Quite interesting is we have minus 12 volt on that board, and I think minus 12 volt is only necessary to control the fans of the machine, because the fans are 24 volt fans, and they use the plus 12 and the minus 12 volt rail to power the fans, and the van voltage is not fixed to 24 volt. It goes from 12 to 24 volts, and down here is a little MOSFET, and I think they control the vans with the voltage of the minus 12 volt rail. This is the only reason why this power supply have minus 12 volt, and the vans are controlled from this logic here. And the third thing is, if you go to the front, we have some connectors here, so you can control the power supply from a master power supply. And this kind of control is also controlled by the logic. You can also hear there's an overtemperature and a fan failure indicator over here. So the coal temperature and fan control is located in the power supply. So there I will solder that in, and I have to go to the downside, because I have to find a way where I can locate the wires. And the only possibility I found is I'm going down outside of the power supply and then through the fan bay up to the bay where the CPU is located, and then outside of the machine. Okay, I will solder it in now, and then we will see us back at the machine. Okay, we are not back at the machine, because I wanted to make some measurings first and record them a second time, but I'm not able to record the measurings a second time. I will tell you about the reason later. I've removed the wires and did the measurings, and the 3.3 volts, the 5 volt and the plus 12 volt are okay. I've got the correct voltage from these 3 lines. The issue is caused by the minus 12 volt line. And the problem was, after I connected the oscilloscope to the minus 12 volt line, the PSU started and the machine started. And these thin wires I've used are not able for long measurements, and so the color of the isolation changed from white to black. And that's the reason why I can't make the measuring again. Interestingly, the electronics in the oscilloscope seems to change the minus 12 line a bit, and then the machine starts. I don't know why that happens. Maybe some of the capacitors I've changed the last time aren't soldered in correctly, and after the first time the machine starts, and several hours later the machine did not start, and it never started again until my measuring. And maybe this distress with the heat caused an issue with the soldering, and the capacitors I've chosen are a bit bigger than the original ones, and now I have also some smaller ones who are fitted in the 3 slots correct. So the physical size is correct, and these are too big. Also, these three capacitors are only used in the minus 12 volt line, not in the plus 12 volt line. Therefore, I will change this capacitor again, and then I will try it out again, and if it starts after I've changed it, I will wait a day, and then I will do it, test it 1 day later again, and if it starts after a day again, then this caused the issue, and the machine will run. But we will see. It is the next day, and yesterday I've changed the capacitors again, and it happens the same thing like the last time. It worked once, and after a few hours I tried it again, and the machine did not start. Therefore, I will check if the control for the fan speed causes the issue, and maybe it kills the capacitors. After the rectifier here is a MOSFET over here, and this MOSFET is a kind of PWM solution for WAN, an very early PWM solution, and I've bridged this MOSFET and removed the gate, and now the minus 12 volt rail should provide full minus 12 volt. Therefore the WANs will run with full power, but you will see if the MOSFET is causing the issue in the whole circuit. I hope that the circuit is able to provide minus 12 volt the whole time, but let's check it and see if it works. Now we are back at the machine, and it is a day later, and yesterday I was able to start the machine, also with a break of several hours, and I have also run the machine for a longer time, for several hours, and there were no issues. I do not smell burnt plastic or something like that, so I think that my little hack in the power supply works. I'm not really able to show if something gets really hot because I'm not able to see inside the power supply with a special camera. Therefore, I do not have several temperature sensors. Therefore, I hope that the circuit will work. So now the next day, I will try if the machine starts again. Yeah, it's working, and it's working the next day, so I think the issue with the power supply has been solved. I did a bit more investigation on the minus 12 volt line, so I have to correct myself and what I said before. The minus 12 volt line is not only for the WANs, also the Q-bus can provide minus 12 volt for several Q-bus cards. And therefore I really don't know what is for what the MOSFET was for, but I do not use cards which use minus 12 volt, and I will use them in that machine with that power supply. Therefore I think there is no real problem with the solution I've choose. And I hope that the machine will work with that solution. So thanks for watching, and leave comments below, and see you in the next episode.